So till now we have seen the magnetic field produced by the current through a straight conductor and how to find out the direction of the magnetic field lines around it. The magnetic field lines around the straight conductor are in the form of concentric circles, and how to find the direction that we have seen by right hand thumb rule. That is, if you imagine to be holding a straight conductor carrying current in your right hand with the thumb pointing the direction of current, then the fingers encircling the conductor or then the fingers around the conductor give the direction of the magnetic field lines. Now we will see the magnetic field due to a circular loop, due to the current through a circular loop. Okay, magnetic field due to current through a circular loop. Let us consider one circular loop like this. This is a circular loop. The current enters the circular loop through the point X and comes out through the point Y. So the current is moving in the loop in the anti-clockwise direction. And if you consider a very small segment of the circular loop, it acts as a straight wire. The current is moving in this direction here. So if you consider like this, that is current is moving in this direction in this segment, then the magnetic field lines will be in this direction. So the magnetic field lines are in the form of concentric circles, and as the circles become larger and larger, okay, they become straighter and straighter. And this is the magnetic field lines, okay, due to the segment opposite to this segment. Okay, and what you find is the direction of the magnetic field lines due to the opposite segments, both are equal, both are in the same direction. So what happens is all the segments, that is all the points on the loop, they produce magnetic field. Each and every point on the loop produces a magnetic field, and this magnetic field at the center will be in the same direction. As a result, the magnetic field produced at the center of the circular loop carrying current will be very strong. Okay, the strength of the magnetic field at the center of the circular loop carrying current will be in the same direction. So a circular loop carrying current produces a strong magnetic field at its center. Okay. So, and not only that, you can further increase or enhance the magnetic field by increasing the number of turns of the loop. If you increase the number of turns of wire in the circular loop, then the magnetic field will increase n times. Okay, then the magnetic field will increase how many times? N times. Okay, take down these notes in your fair, learn and write them, practice by writing them without looking. Okay, take these notes in your fair book. Okay. So, the magnetic field due to a current through a circular loop, let us consider one circular loop as shown in the figure. Current enters the loop through X, comes out through Y. Now since the current is flowing in the anti-clockwise direction, if you consider a very small segment of the loop or a point of the loop, this will be in the form of a straight line. So the magnetic field lines around it will be in the form of concentric circles. So these circles will become larger and larger, and at the center they will form a straight line. And if you consider an opposite segment, a segment just opposite to this segment, this will also produce magnetic field lines in the form of concentric circles. These also circles become larger and larger, and at the center of the circular loop, these magnetic field lines will be in the same direction. Hence, the magnetic field will increase. Each and every point on the loop will produce magnetic field lines, and these field lines will be in the same direction at the center of the circular loop. So, a current through a circular loop produces a strong magnetic field at its center. This magnetic field can further be enhanced or increased by increasing the number of turns of the loop. We can increase the number of turns of the wire here. If you increase the number of turns by n, then the magnetic field increases n times. This is the main advantage of current through a circular loop. Why circular loops are used.